Hello my dear students. Today I am going to teach you Laplace transforms. This is actually the fourth module of MAT-102, that is vector calculus, differential equation and transforms. And the same syllabus we have in MA-202, that is probability distribution, transforms and numerical methods. Okay. Now we are moving on to Laplace transforms. Now let us examine the word first, transform. Transform means the change. If we are considering a function f of t, usually we are taking f of x. In Laplace transform, you take, instead of f of x, take a function f of t. A function f of t changes to an integral. Laplace transform means change. So a function changes to an integral. How the function f of t changes to an integral? Now let us take the definition of Laplace transform. For all t greater than or equal to 0, we are taking the variable as t greater than or equal to 0, the Laplace transform is denoted by a big L, f of t. And you can put a curly bracket like this. So when you are taking L of this function f of t, so you can write L of f of t. It is defined as the integral 0 to infinity e raised to minus st into f of t dt. So look at the definition. It is integral, the Laplace transform of a function f of t. It is an integral. Which integral? It is integral 0 to infinity. Look at the limits of integral. It is from 0 to infinity. E raised to minus st. S is a parameter. E raised to minus st into f of t. F of t, so whatever function we are considering here, the same function we should write here. Okay? F of t into dt. See, this integral is called the Laplace transform of the function f of t. And Laplace transform of this function is denoted by L f of t. Okay. So when you are evaluating this integral, so we are integrating with respect to t, right? And you substitute after integration upper limit and lower limit, you will get this integral as a function of s. Okay, for only t we are substituting upper limit and lower limit. So the answer will be a function of s. Okay, so we can denote the whole integral as another simple capital F of s. Okay, so in total what we can say, the Laplace transform of this function f of t is a function of s, that is f of s. In short form, we can write this as f of s. So what is f of s? It is L of f of t. Okay. So what we have learned? The Laplace transform of a function f of t. It is denoted by L f of t. It is an integral defined as integral 0 to infinity e raised to minus st into f of t dt. And after integrating, you can see this is a function of s. Therefore, we can further denote it as f of s. Okay. We know the definition of Laplace transform. It is L f of t is equal to integral 0 to infinity e raised to minus st into f of t dt. Okay. Now we are discussing we are considering some standard functions, and what are their Laplace transform. So let me take the first function as the constant function. The constant function, it can be taken as f of t is equal to c. C is a constant. What is its Laplace transform? Okay, so here you take f of t is equal to the constant function c. What does its Laplace transform? So L of c. We know L f of t is integral 0 to infinity e raised to minus st into f of t dt. Okay. If f of t is the constant function c, in the same definition you can substitute. So integral 0 to infinity e raised to minus st as it is. And instead of f of t, what we should put? The function here. Okay, the function here is c. So the same c you substitute here into dt. Now we should integrate this. Okay. Since c is a constant, this can be taken outside. Okay. So c into integral 0 to infinity, the same, e raised to minus st dt. And what is the integral of e raised to minus st? On integrating e raised to minus st, it is e raised to minus st divided by the coefficient of t. Coefficient of t we should divide in integration. Okay, remember that. So, divided by minus s. This is the integral. Now you put the limit 0 to infinity. And what is happening when we are substituting the upper limit? You put t is equal to infinity. You can see this becomes e raised to minus infinity. Okay? And the value of e raised to minus infinity. What is the value of e raised to minus infinity? That is 0. Okay? So, on substituting upper limit infinity, we'll get e raised to minus infinity, the value is 0. So, upper limit minus lower limit, right? So, upper limit minus lower limit. When you are substituting lower limit, it is again minus. So, minus of minus, it is plus. And if you are putting t is equal to the lower limit 0, it is e raised to 0. And the value of e raised to 0 is 1. Okay. So, e raised to 0, 1 divided by s. So, in total what we obtained, it is c into 1 by s or c by s. So, what we proved here? If you are considering the constant function, that is c, its Laplace transform is c by s. Okay, this is the first result. The Laplace transform of the constant, that is L of c, what we proved, L of c is equal to c by s. C by s. This is the first result. So like that we are considering different types of function. Here we considered the constant function, and next we will consider an algebraic function, trigonometric function, etc. and calculating the Laplace transform of those functions. Okay. We have the first result, L of c is equal to c by s. So what will be L of 1? If the constant c is 1, so what will be the Laplace transform of 1? You can substitute in this equation. Okay. So L of 1 is 1 by s. So what will be L of 2? L of 2, c is 2, right? So substituting in this equation, it is 2 by s. Then what is L of 10? It is 10 by s. So like that, we can calculate Laplace transform of any constant. Now we have the second result, L of e raised to 80. L of e raised to 80, that is equal to 1 by s minus a. L of e raised to 80, we want to prove this is equal to 1 by s minus a. So let us start with the definition. L of, by definition, this L of f of t, f of t is equal to integral 0 to infinity e raised to minus st into f of t dt. Okay. So you start with L of e raised to 80. That is equal to integral 0 to infinity e raised to minus st into e raised to 80 dt. Here f of t is e raised to 80. So the same f of t you have to multiply here. So e raised to 80 dt. Now e raised to minus st terms exponential. By the exponential rule, we know a raised to m into a raised to n, it is a raised to m plus n, right? So these two exponential, when I am combining, this is e raised to, let me take a minus sign outside. So we'll get minus of s minus a into t. You can verify whether we'll get the same answer or not. So you multiply minus s into t, it is minus st, minus into minus plus a into t, so at. Okay, so e raised to minus of s minus a into t dt. Now we should integrate this one. What is the integral of this function? It is e raised to minus s minus a into t divided by minus of s minus a. We know in integration the coefficient should be divided. Okay, so minus of s minus a with the limits 0 to infinity. Now you first substitute upper limit, then the lower limit. You can see when you are substituting upper limit as infinity, in the place of t, when you are putting infinity, it is e raised to minus infinity, that will be 0. Okay, so upper limit will be 0 minus the lower limit, put t is equal to 0. So we will get e raised to 0. E raised to 0 is 1. Okay, so 1 by minus of s minus a. So minus of minus, it becomes plus 1 by s minus a. So this is the second result, e raised to L of e raised to at, that is equal to 1 by s minus a. Now let us take an example. See, we have learned L of e raised to at, the result is 1 by s minus a. Now what is L of a raised to 2t? Instead of 80, we have 2t. So by using this result, it is 1 by s minus 2. S minus a is 2. A means it is coefficient of t. Okay, so 1 by s minus 2. Now, what is L of a raised to 5t? L of a raised to 5t, it is 1 by s minus 5. Then, what will be L of a raised to minus t? See, in this example, coefficient of t is minus 1. Okay. So, 1 by s minus minus 1. That will be s plus 1. So, L of e raised to minus 80 is 1 by s plus 1. Now, come to L of e raised to minus 2t. L of e raised to minus 2t, that is equal to 1 by s plus 2. How? Coefficient of t is minus 2. So, in the result 1 by s minus a, if you are substituting, a is minus 2. Okay. So, 1 by s minus minus 2, that is 1 by s plus 2. Okay. So, what we have learned? The second result, L of a raised to 80 is equal to 1 by s minus a. Now, we have the next result, L of t raised to n. We are considering the third function as t raised to n, the algebraic function. What is its Laplace transform? L of t raised to n is n factorial divided by s raised to n plus 1. We are proving the Laplace transform of t raised to n as n factorial. We know factorials. Okay. N factorial means 1 into 2 into 3 into up to the product up to n. 3 factorial means product up to 3. So, n factorial divided by s raised to n plus 1. You look at the power. If the power is n, the same n factorial, and in the denominator, the power of s is n plus 1. One more. Okay. Now, we are proving this result. We are applying the definition of Laplace transform. L of t raised to n, that is equal to integral 0 to infinity e raised to minus st into t raised to n dt. See, whatever function here we are writing, the same function we should write here. Okay, t raised to n dt. See, in order to integrate this function, what I did is, I am integrating this by substitution method. Okay, so for that you put st is equal to another variable, say u. Therefore, t is equal to u by s. So, on differentiating both sides, you will get dt its derivative dt, u its derivative du by s. So dt can be replaced by du by s. Now you substitute in the integral. St is replaced by u. So e raised to minus u into t is replaced by u by s. So u by s the whole raised to n. dt is replaced by du by s. Okay. Therefore integral 0 to infinity e raised to minus u into u by s the whole raised to n is u raised to n by s raised to n. And already one more s we have. So combining those two, we'll get s raised to n plus 1. Okay. 1 by s raised to n plus 1 can be taken outside. So 1 by s raised to n plus 1 into integral 0 to infinity e raised to minus u into u raised to n. See, the remaining is u raised to n only. So I am just making some adjustment here, okay, in order to get a particular type of function. What I made here is I added 1 and subtracted the same number into du. You see what I did here? Just look at this step. Integral 0 to infinity e raised to minus u into u raised to n only we have, isn't it? And there I added 1 and the same one I subtracted, okay. Now just a rearrangement. So 1 by s raised to n plus 1 into integral 0 to infinity e raised to minus u into u raised to n plus 1 minus 1 du. This n plus 1 I substituted here, n plus 1 I made a bracket here, a simple bracket. So 1 by s raised to n plus 1 into integral 0 to infinity e raised to minus u into u raised to n plus 1 minus 1. See, this integral is a particular type of integral that is called the gamma function. Okay, so in order to move on to the next step, you have to just learn what is gamma function. See, here I wrote the definition of gamma function. An integral of a particular form. The form is integral 0 to infinity e raised to minus x into x raised to n minus 1 dx. That is denoted by gamma n. So you look at this integral, what is gamma n? If the integral of the form integral 0 to infinity e raised to minus a variable into the same variable raised to a number minus 1. See, this number minus 1 dx, that is equal to gamma of this number. The number here is n. If it is m, then it will be gamma m. And you can express this integral in terms of any variable. See, instead of x, you can use y also. If you are writing in terms of y, then gamma function is integral 0 to infinity e raised to minus y into y raised to n minus 1 into dy. The symbol is independent of the variable. Okay, it focus only on this power, the number minus 1, the same type of integral we have here. This definition is in terms of the variable u. See the integral, it is integral from 0 to infinity e raised to minus a variable into the same variable raised to a number minus 1, a number minus 1. It is gamma of this number, and gamma is denoted by a division symbol. This is not square root, just a division symbol. This is a notation for gamma. So gamma of n plus 1. So the whole integral can be replaced by gamma n plus 1. So 1 by s raised to n plus 1 into gamma n plus 1. Now we have a property of gamma function that also you have to remember. The property says that gamma n plus 1 is equal to n factorial. This is actually called the reduction formula. Okay. So by using reduction formula, gamma n plus 1 is replaced by n factorial. Therefore, the result n factorial n factorial divided by s raised to n plus 1. Okay. Therefore, what we proved? the Laplace transform of t raised to n is equal to n factorial divided by s raised to n plus 1. But remember, this factorial symbol, factorial is defined only for positive natural numbers. Defined for natural numbers, not for integers. So when n is a natural number only, you can use this result. Okay. Otherwise, what is the formula? Suppose n is any positive integer. Then L of t raised to n, you can write by using gamma symbol. It is gamma n plus 1 divided by s raised to n plus 1. So, in two ways you can express L of t raised to n. One is n factorial by s raised to n plus 1. This is applicable when n is a natural number. Okay. And gamma n plus 1 by s raised to n plus 1 for any positive integer. Okay. So we have the equation L of t raised to n is equal to n factorial by s raised to n plus 1. This is applicable when n is a natural number, or you can write L of t raised to n is equal to gamma n plus 1 by s raised to n plus 1 for all the other positive values of n. Okay, now let us take one example. What is L of t? L of t. It is t raised to 1. So in the place of n we have 1. So by the definition it is 1 factorial divided by s raised to n plus 1. N plus 1. N is 1. So 1 plus 1 it is 2. So 1 by s square. L of t square. What will be L of t square? N is equal to 2. Therefore by the definition it is 2 factorial by s raised to n plus 1. N is 2. 2 plus 1 3. 2 factorial by s cube. 2 factorial is 2 itself. 1 into 2, that means 2. So 2 by s cube. Now L of t cube. Here n is equal to 3. N is equal to 3. Okay. L of t cube, that is 3 factorial divided by s raised to 4. Okay. S raised to 4. 3 factorial means 1 into 2 into 3. That means it is 6 divided by s raised to 4. So like that we can find the Laplace transform of algebraic function. Now what will be L of t raised to half? When n is a fraction like t raised to half. In this case you have to use the second formula. It is gamma of n plus 1. N plus 1 means 1 by 2 plus 1 divided by s raised to n plus 1. N plus 1 is 3 by 2. So gamma of 3 by 2 divided by s raised to 3 by 2. Now the next example. L of t raised to 3 by 2. This is here n is a fraction again. So use the second formula. It is gamma of 3 by 2 plus 1 divided by s raised to 3 by 2 plus 1. It is 5 by 2. Therefore, it is gamma of 5 by 2 divided by s raised to 5 by 2. We have for gamma 5 by 2, we have further simplification by using the reduction formula of gamma function. But I am not going to that since gamma functions are not included in your syllabus. Okay, so you can write up to this gamma 5 by 2 by s raised to 5 by 2. Okay. Now we have the fourth standard function. It is sin 80. So we are here calculating the Laplace transform of sin 80. L of sin 80. The result is a divided by s square plus a square. A means it is coefficient of t. So L of sin 80 is equal to a divided by s square plus a square. So we are proving this result here. Okay, let us start with the definition of Laplace transform. So once again you remember the definition. Okay, L f of t is equal to integral 0 to infinity e raised to minus st into f of t dt. Okay, here f of t, in this case f of t is sin 80. Therefore, integral 0 to infinity e raised to minus st into sin 80 dt. And this integral, I am doing this integral by integration by parts. So for that, let me name this definite integral as I. Okay, let me name this integral as I we should calculate. Okay. And we are doing by integration by parts. We know I-late principle. See here, which function can be considered as the first and which one as the second function. That depends upon the I-late rule. I-late. So E is the exponential, sine is the trigonometric function. So T comes first, right? So trigonometric function, you take trigonometric function as the first function and E as the second function. So first function sine 80 into integral of second function. Integral of second function means it is e raised to minus st by minus s. Coefficient of t we should divide with the limit 0 to infinity minus integral of derivative of first function. Derivative of first function. Sin 80 whose derivative? It is cos 80 into a. Okay, so a cos 80 into integral of second function. Same term e raised to minus st by minus s into ds. See, in the first term, when you are applying upper limit and lower limit, what is happening? So you can see when you are putting upper limit, it becomes e raised to minus infinity. One term here we have it as e raised to minus infinity, that is 0. So on putting upper limit, this will be 0. And when you are substituting the lower limit, it is sin 0 into this. Okay, so on substituting both upper limit and lower limit, the first term vanishes. Okay. Now we have only the second term. So minus of minus, it is plus a by s, it is a constant, can be taken outside. A by s into integral 0 to infinity e raised to minus st into cos 80 dt. Now we are integrating this function. Okay. And again this can be done by integration by parts. You can take cos 80 as the first function and exponential as the second function. Do integration by parts again. So a by s into the first function cos 80 into integral of second function e raised to minus st by minus s with 0 to infinity as the limits minus derivative of first function cos 80, its derivative is sin 80 minus sin 80 into a. So minus a sin 80 into integral of second e raised to minus st by minus s. Now look at the first term. So when you are substituting upper limit, it becomes e raised to minus infinity, that is 0. And when you are substituting lower limit, t is equal to 0, this is cos 0 into e raised to 0 by minus s. Cos 0 is 1. E raised to 0 is also 1. So upon substituting upper limit, we have 0 and on lower limit it is 1. So 1 by s minus, see, 3 negative signs we have. So minus, minus, minus. So it is altogether it is negative. A by s can be taken outside. A by s. Now look at the remaining term. It is integral saying 0 to infinity e raised to minus st into sin 80 dt. See, already we assumed e raised to minus st sin 80 dt as our I. Okay, so this function is the remaining term is, it is nothing but it is I. Okay, so a by s into 0 plus 1 by s minus a by s into I. So on multiplying it is a by s square minus a square by s square I. We started with I, right? Now you take the term containing I to LHS. So I plus a square by s square I is equal to a by s square. So on simplifying, you will get s square plus a square by s square I equal to a by s square. S square get cancelled from both sides. So I is equal to a by s square plus a square. And what is I? I is nothing but the integral 0 to infinity e raised to minus st into sin 80 dt. And that is equal to L of sin 80. So what we proved? L of sin 80 is equal to a divided by s square plus a square. A few examples of this function. See, we have learned L of sin 80 is a by s square plus a square. Can you calculate L of sin t? L of sin t. So what is the coefficient of t? Coefficient of t is 1. Okay. So 1 divided by s square plus 1 square. 1 square. It is 1. So 1 by s square plus 1. L of sine 2t. L of sine 2t. What will be A? A is 2. So 2 divided by s square plus a square. 2 square. That is 4. So 2 by s square plus 4. L of sine 5t. What is the value of A? A is 5. So L of sine 5t is 5 divided by s square plus 25. Now we have L of cos 80. L of cos 80, see the equation? It is S divided by S square plus A square. In sin 80, can you recall? In sin 80, the numerator is A. But in cos, the numerator is S. S divided by S square plus A square. You can prove similarly what we did in the previous case. Similarly, you can prove this result also. You can start with L of cos 80. By the definition, it is integral 0 to infinity e raised to minus st into cos 80 dt. And we can proceed same as in the previous case. You can name this integral as I, then do integration by parts method, then integrate, and finally somewhere on RHS you will get the same I. You take that I term to LHS and do simplification. I'm leaving to you. You calculate L of cos 80. Okay, so keep in mind this result. L of cos 80 is equal to, it is S divided by S square plus A square. L of sin 80 is A divided by S square plus A square. Whereas in cos, it is S divided by S square plus A square. We know L of cos 80 by the definition, it is S divided by S square plus A square. Let us consider this example. L of cos t. So what is the value of A? A is 1. Okay. Therefore, S divided by S square plus A square. A is 1. So S square plus 1. It is very simple, right? L of cos 2t. What is the value of L of cos 2t? It is S divided by, remember always the numerator is S. Okay, S divided by S square plus A square. The value of A is 2, so 2 square, it is 4. L of cos 5t, A is 5. Therefore, it is S divided by S square plus 5 square, that is 25. Now look at the next result. Result is 6. Here we are considering another function sin h80. We know sin h means it is hyperbolic sine. Sin h80, its Laplace transform is A divided by S square minus A square. See, in sin 80, it is A by S square plus A square. But in hyperbolic sine, it is minus A divided by S square minus A square. How do you prove this result? You start with the definition L of sin h80. See here, instead of integrating, we are using another technique for finding the Laplace transform of this function. So what is the definition of sin h80? Sin h80 is, by the definition, it is e raised to 80 minus e raised to minus 80 divided by 2. See, you might have learned the definition of sin hx. It is e raised to x minus e raised to minus x divided by 2. Instead of x, in this case we have 80. Therefore, L of e raised to 80 minus e raised to minus 80 divided by 2. Since 1 by 2 is a constant, that can be taken outside. So 1 by 2 into L of e raised to 80 minus e raised to minus 80. See here actually there are two functions, right? One is e raised to 80 and the other is e raised to minus 80. There is a principle called the linearity principle. If two functions whose sum or difference we have, separately you can put Laplace transform for each function. So here for e raised to 80 and e raised to minus 80, you can apply Laplace transform. Therefore, 1 by 2 into L of e raised to 80 minus L of e raised to minus 80, and this principle is called the linearity principle. Suppose two functions f and g we have, then L of f plus g, that is equal to L of f plus L of g. So like that we can split the Laplace transform. Now look at the first result. L of e raised to a. T by the definition it is 1 by s minus a. L of e raised to minus a. T we proved already 1 by s plus a. Now you simplify this. Take this as the LCM. So s plus a minus s minus minus it becomes plus a divided by s minus a into s plus a. This is of the form a plus b into a minus b, that is a square minus b square. So s square minus a square. Now in the numerator s and minus s get cancelled. So a plus a, it is 2a divided by s square minus a square. Again this 2 get cancelled, isn't it? So the remaining term is a divided by s square minus a square. So what we proved here? It is L of sin h at, that is equal to a divided by s square minus a square. Okay. Now you consider few examples of this result. Sin h at, the result is a by s square minus a square. So sin h t, so what is the coefficient of t? That is a, right? That is 1, isn't it? So here sin ht will be 1 by s square minus 1. Sin h2t, the value of a is 2. Therefore 2 divided by s square minus 2 square, that is 4. Sin L of sin h3t, that is equal to 3 divided by s square minus 3 square, that is 9, and so on. Okay. L of cos h at. See the last result, that is 7. L of cos h at is equal to s divided by s square minus a square. We know in cos, the trigonometric cos function, L of cos at, it is s divided by s square plus a square. See, this is the hyperbolic cos function. Cos h at, that is equal to its Laplace transform as s divided by s square minus a square. We can prove this result by using the definition of cos h at. L of cos h at is equal to L of, see, cos h at, the definition of cos h is e raised to at plus e raised to minus at divided by 2. And you can prove this result by using the same method as we discussed in the previous equation. Okay, you can apply linearity principle, then consider the Laplace transform of e raised to at and e raised to minus at separately and do simplification. You will get the same answer, s divided by s square minus a square, and I am leaving to you. Just calculate L of cos h at. So we have L of cos h at is equal to s divided by s square minus a square. Now here we are calculating cos h at whose Laplace transform. L of cos h t. Here coefficient of t is 1. Therefore the a value will be 1. Okay. So s divided by s square minus 1 square. That means 1. L of cos h2t, what is the Laplace transform? L of cos h2t, that is s divided by s square minus 2 square, that is 4. So s by s square minus 4. Okay. Now L of cos h5t, a value is 5. Therefore L of cos h5t, that is equal to s divided by s square minus 25. And very easily we can calculate Laplace transform of these functions also. Now we have some, I'm writing all these 7 equations. We just go through the 7 equations. See, we have derived all the results. The first one, L of C, it is C by S. L of a raised to at, it is 1 by s minus a. L of t raised to n. 2 definitions we have. The first one is n factorial by s raised to n plus 1 or gamma n plus 1 divided by s raised to n plus 1. L of sine 80, that is A by S square plus A square. Then L of cos 80, it is S by S square plus A square. L of sin H 80, it is A by S square minus A square. And the last result, L of cos H 80 is equal to S divided by S square minus A square. So you have to learn all these 7 results in order to do problems based on Laplace transformations.